Right, so let's talk a little bit about density now. So density, before we start talking about the definition, just answer this question or these questions right here. Which do you think would have the greater volume? Which do you think would have the greater mass, and why? So between a kilogram of feathers and a kilogram of rocks, first of all, let's start with this. Which do you think has, and let me bring this highlighter, has the greatest volume? Remember, volume is the amount of space that something takes up, right? So if you're thinking about a kilogram of feathers and a kilogram of rocks, which one has more volume? Again, the space something takes up. And then the other part of that is which one has more mass? And mass is basically how much something weighs, right? Let's just think of it like that. So, first of all, if you had a kilogram of feathers and a kilogram of rocks, which one would take up more space? A kilogram of feathers or a kilogram of rocks? So if you answered that the feathers would take up more space, more volume, then you're right, because you're going to need more of those to equal the same amount of kilograms as a rock, right? So the feathers are going to take up a lot more space than the rocks would. But if you're talking about which one has a greater mass, well, the answer to that, it's kind of like a trick question right there. Which one has the greatest mass? Well, they're both 1 kilogram, right? So 1 kilogram and 1 kilogram, they have the same amount of mass. So a kilogram of feathers, and that's kind of one of those riddles. Which one weighs more, a ton of feathers or a ton of rocks? And most people are going to say the rocks weigh more, but a ton is a ton, right? You have the same amount. They both weigh the same. It's just the volume is what's going to be different, right? A ton of feathers, you're going to need so many more feathers to make up that volume than you are going to need rocks, right? Because rocks won't take up as much space. So here again, the volume for both of these, the feathers will take up more space. A kilogram of feathers will take up more space than a kilogram of rocks, but the mass they're the same. A kilogram of feathers is the same as a kilogram of rocks, right? So that last one's kind of like a trick. So here you have density, right? This is a good visualization right here because density, remember this, density is defined as mass per unit volume, but basically it's just saying how compact something is, right? How tightly packed something is. And there's so many different examples of of density. One of the ones that I usually like to share with students is like pancakes, right? A pancake, if you've ever had a dense pancake, that thing will like sit at the bottom of your stomach and it's like eating a rock or some kind of rubber, right? That is not the kind of pancake you want. But a pancake that is less dense is like light and fluffy. And that's because of all the air that goes through a fluffy pancake, right? It's full of bubbles and gas, and that's what makes it light and fluffy, right? So look at these little pictures right here, right? The one on the right, this one that I'm circling, is more like that fluffy pancake. It's got a lot of air in it. It's light and fluffy. This other one right here on the left, that's like that thick pancake that's like chewing on rubber, right? And if you put it in water, it'd probably sink to the bottom of whatever container you're putting it in, because that's what density is like how compact something is. Something that is not as dense is like lighter and has more space inside of it. All right, so which is less dense? When it comes to H2O, is water less dense or is ice less dense? So remember this, whatever is going to be less dense is going to float to the top, right? Even if you think of something like a gas. So think about helium. Why does a helium balloon float to the top and a balloon that you blow up on your own just hits the ground, right? It's because helium is less dense than the carbon dioxide that you exhale, right? And helium is less dense than the air that's in our environment, and that's why helium will float above the air, right? So in this case, think about this. What is it that floats? So you pour yourself a glass of water and you have ice in it. Which of those floats above the other? And even just think of an iceberg, right, in the ocean. If you think of these, it's easy to realize that water is the one that floats, or sorry, ice floats on top of water, right? A substance floats if it is less dense than the other components in a mixture. So in this case, we have water. And it says here, ice is approximately 9% less dense than liquid water. So again, if something is less dense, it's going to float on top. A while ago, I made a mixture with syrup, oil, and water, and I put it in a flask, and I kind of shook it up. And we noticed, and remember, this is a heterogeneous mixture that we talked about, right? The syrup floated or sunk to the very bottom. The oil hung out in the middle, and the water, which was less dense of all three, floated at the top of that mixture, of that heterogeneous mixture, right? So it showed us again that water is less dense than the others. The oil not was less dense than the syrup, but it was more dense than the water, and that's why it hung out in the middle. And then the syrup was the most dense out of all of that, and that's why the syrup just hung out at the bottom of that container, right? Because it was the most dense. So to find density, so here, this is where the math comes into play, right? To find density, there's a few things we need to know about an object to find its density. So we got to find the mass of an object, and that's why you see this triple beam balance right here. We use digital scales in our classroom for the experiments that we've done, but this is, you could use a triple beam balance just the same. Then when you find the mass of an object, you also have to find the volume of that object. And the volume of the object, like you can see right here, the way they found the volume of this marble is they started off with a certain amount of liquid in there, and that's 20 milliliters. You drop that marble in the water, and then the water goes up, the water level. And so basically, you just have to take whatever you started off with, and then whatever you ended up with, and subtract what you started off with from that, and that's how you find the volume of something. For most of the problems we're going to be working on, they already give you the volume, so it's pretty much just a matter of identifying which is a mass, which is a volume, and then plugging it into this formula right here that you see. And this formula, like it says, is density is equal to mass divided by volume. Right? So basically you would find the mass and you would put it on top, and then you find the volume and put it on the denominator, and it would just be mass divided by volume. Right, so here we have an example of this. And this right here, this little triangle is a good tool to use if you have a difficult time trying to remember the formula. Right, so if you're looking for, let's see, units for density are grams divided by centimeters cubed or grams divided by milliliters. Right, so what you're going to see is that whenever you answer a question for density, whenever you give the answer, so let's say the answer is like 8, right? 8 is the number you get, but that's not enough. That's not going to be the complete answer. You're going to have to write down 8 grams divided by centimeters cubed, right? Or if it uses centimeters cubed, but if the question uses like this, whoops, let me go back real quick. But if the question uses milliliters in there, you're going to have to answer 8 grams divided by milliliters cubed. And sorry, I keep switching on me because of this. So yeah, just know that that's how you're going to have to, whenever you give an answer, you're going to have to use these units. So the example right here, let's see, let's go to the example. And let me erase this right here. Oh, but what I was saying is this is a good tool right here to use. So if you're solving for density, like we're going to be doing right now, the first thing you want to do is you cross out this, or you put your finger over that to hold it, and you just see that it's mass divided by volume, right? And if you're looking for mass, you would just cover the M right here, and you would see that it's density times volume, right? And if you're looking for volume, you would just put your finger over this volume right here, and then you just do mass divided by density, right? So as I was saying right here, you have all the formulas there available to you. So again, if the question is asking you for mass, it's just density times volume. If it's asking you for volume, it's mass divided by density, right? If it's asking you for density, it's mass divided by volume. And here's the thing to remember. If they're asking you for mass, usually you're going to answer in grams, right? Because grams is a measurement for mass. So, if you give an answer for mass, it's going to be in grams. If you give one for volume, remember, it's either going to be, and let me erase this right here, centimeters cubed, or it's going to be milliliters, right? So, and if you're answering for density, that's where I was saying right here, it's either going to be grams divided by centimeters cubed, or it's going to be, and let me kind of bring this down a little bit, grams by milliliters. Right, and we'll see you'll see what I mean in a second. So let's look at this example right here. For this example, remember the steps that you have to follow, right? First is you got to find the mass of the object, then you got to find the volume of the object, and then you just have to divide mass divided by volume. And so here they're giving you some of the information. right? So right here, you see that you have 35 grams. So right there, grams, remember grams is telling you the mass of something. So you have M, right? So, but if you look right here, the next thing they give you is 7 centimeters cubed. So remember, centimeters cubed means volume. So you have mass and you have volume. And then right here, they're straight up telling you calculate the density, right? So they're telling you to calculate the density, which means we're going to be using this one right here, right? Density equals mass divided by volume. So then you just got to plug that in, put the mass on top, put the volume on the bottom, and then divide, right? So again, set up the problem like this, right? They gave us the mass, 35 grams. Unknown is the density. We don't know what that density is, but they gave us the volume right here, 7 centimeters cubed, right? And then the formula is density equals mass divided by volume. So all you got to do is plug that in, right? You know that the M is stands for mass, right? And here they're giving you 35 grams. That's a mass. Then volume right here, you know that centimeters cubed is for volume, and they're putting that number at 7 centimeters cubed. So you just plug it in, right? This volume right here is going to be 7. So then you get density is equal to 35 grams divided by 7. So what is 35 divided by 7? Right here, you see it is 5. Right? But again, like I mentioned, it's not enough just to put that 5 there. You also have to put the units, which are grams by centimeters cubed. And you know you're using that centimeters cubed and not like it says right here, grams divided by milliliters, because in the problem, they're giving you centimeters cubed. That's why you know it belongs right here. Right? So that is how you do density is you solve for, or you find the mass, you find the volume that they give you, and then you just mass divided by volume. If they had been asking me for the mass of something, I would have just found the density and multiplied it by the volume. If they were asking me right here, solve the volume instead of calculate the density, they could have said calculate the volume, and then I would just have to find the mass and divide that by the density. So right, it all depends on what they're asking you for. You go and find the two things that they're giving you in the problem. In this case, 35 grams is a mass, 7 centimeters cubed is a volume. I have M, I have V, and then they're asking me for density. So then you just got to plug that in. Density is equal to mass divided by volume, and that is your answer.